Okay, so the final lesson of the trig unit, lesson 5.5. This lesson is all about doing word problems. Okay, so there's no new content being taught. All we're going to be doing is applying either the trig ratios, so dealing with right angle triangles. Okay, so just highlight. This is when you have right triangles, as I said in the previous lesson. Or you're going to be dealing with the sine law or cosine law. And again, these two right here and here are for non-right triangles. Okay, so we have 4 problems in today's lesson. Let's just get right into it. So example 1, Brandon has a triangular backyard with sides 27 meters, 21 meters, and 18 meters. He wants to fertilize the entire garden, but only has a bag that covers 400 meters squared. Does Brandon have enough fertilizer to cover the garden? So draw a picture, okay? So draw out. It's a triangular backyard. Okay, so we know we're dealing with a triangle. And when you're drawing out your triangles, you can never assume 90 degrees, okay? You have to assume that it is a non-right triangle unless otherwise specified. So we have a triangular backyard. As we label it, let's start, just give it labels for the vertex, and then give the side lengths. So we'll just call this one 27, we'll call this one 21, and we'll call this one 18. It really doesn't matter how you actually label them, as long as you're consistent with the letters. So, does Brandon have enough fertilizer to cover the garden? Well, he has enough fertilizer to cover 400 meters squared, okay? So that is an area. So the max he has is for 400 meters squared of area. Well, how much area is this? Well, that means we need to apply our area formula, which is area is base times height divided by 2. Well, we have our base, right? The base of the triangle is this value right here. But what we don't have is we don't have the height of the triangle, the height right here. This is unknown. So in order to solve that height, if you can visualize a triangle, like a right triangle, like we have, I'm just going to highlight in blue right here, and right here, well, to get that h value right there, we have the hypotenuse of that blue right triangle I've drawn. So all we really need is this theta right here. Okay, once we get that theta, eventually we are going to use the ratio cosine theta is going to give us our opposite, which is the h that we're looking for, divided by the hypotenuse, which is at 27, that value there. And so as soon as we find this value right here, this will be our only unknown. And then once that's your only unknown, you can solve it. So to get this theta right here, well, that is one angle inside of the big purple triangle I drew. Well, if you have 3 side lengths of a triangle and you're looking for an angle, you're going to be using the cosine law to get that. So let's set up our cosine law. And once again, I'll just draw the triangle really quickly, just so you can have a better picture without that blue triangle on there. So this is A, this is, I call this one B, I call this one C. We are looking for this theta right here. Well, we have little side length B, which was 18. We have little side length C, which was 27. And we have little side length A, which is 21. So we are setting up the problem to find angle B. So we have cosine B is equal to C squared plus A squared minus little b squared, all divided by 2CA. Alright, so now just plug in everything that you have. Cosine B, the angle what we're looking for, is 27 squared, that's what little c is. A is 21, so square that. And then take away B, 18. square that. Divide this by 2 times C is 27 and A is 21. Okay, let's clean up our numerator. So let's go 27 squared plus 21 squared, subtract 18 squared, so 27 squared plus 21 squared minus 18 squared. So up top here, we're going to get a value of 846. And on the bottom, it's 2 times 27 times 21. That is a value of 1134. So cosine B is 846 divided by 1134. So then angle B is the cosine inverse of this fraction, 846 divided by 1134. So 846 divided by 11, oh, I put that in my calculator wrong, sorry. 846 divided by 1134, shift cosine inverse answer, I get an angle of B being 41.7. Actually rounding it up, 8 degrees. Okay, so now we found that angle. Well, that angle is the angle that is part of that blue triangle I drew. Where actually, so I don't run out of room, I'll do it over here. I'll do the top. So we have this triangle here, where this right here was the H we're looking for. We just found this angle right here to be 41.8, and we have this side length right here to be 27. So we have an angle and its opposite. So, oh, I put cosine here. Jeez, that is a, I'm sorry, that is sine theta. So we have an angle, so this is sine theta is going to be H over 27. And that theta, this, is that angle we just found. So sine 41.8 is H over 27. So multiply both sides by 27. 27, these cancel. And you get 27 sine 41.8 is equal to H. So 27 times sine 41.8, that is H being equal to 17, okay, 18 roughly, once you round it. 18, and our units are meters. So then our final area is area of our plot of land is base times height over 2, and this base right here is this 21 right here of the big purple triangle. So that's equal to 21 times 18 over 2, which would be, and I'm going to just reduce all this size right here. Actually, never mind, that'll just mess things up. 21 times 18 divided by 2, we have 189 meters squared. So yes, Brandon has lots of fertilizer because he had enough to do 400 meters squared. Our triangle is only taking up 189 meters squared. So lots of room. So therefore, lots of fertilizer. Actually, not lots of fertilizer. More. Enough fertilizer. So I'm struggling on the wording here. Enough fertilizer. Fertilizer for the backyard. Perfect. Okay. So you see how we had to combine cosine law and your primary trig ratio to be able to solve that problem. Let's see another example. Example 2. The length of the sides of a hut is 1.8 meters long. What is the maximum distance between the bottom sides of the hut if the angle at the top is 35 degrees? Round your answer to the nearest tenth. Okay, so like a hut, it's like those indigenous huts. So where, you have like a shelter like this, and like, this would be like your doorway here. It's being supported like that. So it's saying that these lengths right here are 1.8 meters right here and here. And it's telling you that at the top right here, this is an angle of 35 degrees. So the question is saying, well, what is this side length right down here, this opposite of that angle? Okay, well, let's think about what pieces of information are given here. This is a non-right triangle, because again, you assume it's non-right. You have an angle that is wedged between two side lengths. So this is, once again, a cosine law problem, all right? And we are setting it up to find this side length right here. So let's call that side length, we'll keep it as x, all right? And then we'll call this side length A and this one B. So our problem, when we set it up, is going to be x squared is equal to a squared plus b squared minus 2ab cosine angle x, right? Remember, the angle is the one that's opposite the side length. So we're looking for this x, but we have a is 1.8 squared. We have b is 1.8 squared. 2a 1.8, b 1.8, cosine, and then our 35 degrees. So x squared is, and now let's just plug it all in, so 1.8 squared plus 1.8 squared. So these first two terms right here, they simplify to become 6.48, and then let's do the backside. 2 times 1.8 times 1.8, we get minus 6.48 cosine 35. So now let's just clean all of that up. So it goes 6.48 minus 6.48 times cosine 35. And I get 1.17. Square root that, and you get x to be equal to, square root this answer, you get x to be equal to 1.08 meters. Round answer to the nearest tenth of a meter, so that means x is equal to, after we round, 1.1 meter. So what is the maximum distance between the bottom sides of the hut? Well, therefore, max distance is 1.1 meters. Perfect, that was much more straightforward. Let's look at example 3. So I'm just going to get a drink. Okay. A hockey net is 1.83 meters wide. Vanessa is standing 5 meters from one side of the net and 6 meters from the other side. Alexandra is standing 6.5 meters from one side of the net and 8 meters from the other. Who has a greater angle of view of the net? All right, so let's draw, so that way our picture doesn't look so confusing. Let's just draw them separately, okay? But, you know, in the real world, they'd be kind of standing on the same ice, looking at the same hockey net. But if we have Vanessa's, let's do Vanessa's work over here. So Vanessa's work. So she is standing, there's a hockey net, right? You know, the hockey nets are in red. This is saying this hockey net is 1.83 meters. And Vanessa is standing maybe over here somewhere. It's saying that from one side of the net, Vanessa is standing 5 meters. And from the other side of the net, so to this edge of the net right here, it's 6 meters. Okay. And then the question is saying, well, who has the greater view of the angle? Well, you're looking for this theta right here. And then we have the same going on with Alexandra. So Alexandra, you know, is still the same hockey net, right? 1.83 meters. But she's standing, 6.5 from one of them, so, you know, a little further. So right here, and she might be 6.5 from this one, and it's saying she is 8 from the other. So this side length right here is 8. And once again, we are looking for this theta right here, okay? So let's call them theta 1 and theta 2. We're just going to compare theta 1 to theta 2, okay? Because the question is saying, who has the greater angle of view of the net? So what that means is essentially if one angle, you're just looking at the two angles and you're saying, well, is theta 1 bigger than theta 2 or vice versa, all right? Whoever has the bigger angle has the greater angle of view. So let's find those angles. So theta 1, how do we get that? Well, we have drawn a triangle right now that has all three sides being defined with an unknown angle. So this is a cosine law problem, once again, where the unknown is the angle. So you set it up to find cosine theta. We'll designate it theta 1 so there's no confusion. All right. Well, there is the opposite side length. Okay, so just keep in mind where that 8.3 goes. So you're setting this equal to the 6 squared plus the 5 squared, and then you take away that 1.83 squared. And then what goes on the bottom is 2 times that 6 and that 5. Okay? So let's do our math. So 6 squared plus 5 squared minus 1.83 squared. So up top here, and I'm just going to write it out. That's a lot of decimals, but let's just keep our answer accurate. So 557.6511. And on the bottom, 2 times 6 times 5, that would be 60. So we'll go 57.6511, divide that by 60. I get an answer of 0.961. And remember, that's what cosine theta 1 is equal to. So in order to get theta, we need to then take the cosine inverse of that 0.961. And if we do that, we are going to get, shift cosine inverse answer, we are going to get 16, and does it say to round? Nope, let's just go to one decimal place. 16.1 degrees. Okay, so that means Vanessa's angle of view to the net is 16.1 degrees. So let's box that just so it's easier for us to find. And now let's do the same math, but for Alexandra, okay? So we're setting up the problem once again for cosine, but this time theta 2. And so you add your side lengths, 8 squared plus 6.5 squared, and then you take away the side length that's opposite the angle you're looking for, so 1.83 squared, and then divide this by 2 times 8, 6.5. And again, you will be given these formulas, okay? So you're not expected to memorize it. So cosine theta 2 is equal to, let's clean up the top, so 8 squared plus 6.5 squared, take away 1.83 squared. So our numerator up here cleans up to be 102.9011, and on the bottom, 2 times 8 times 6.5 is 104. So now go 102.9011, and you divide that by 104. So you get cosine theta 2 is equal to 0.9894, and then theta 2 is the cosine inverse of that 0.9894. So then you get an angle, after you do shift inverse, of 8.3 degrees. So then if we compare our two angles, right, well, you can see that 16.1 degrees is bigger than 8.3. So that means Vanessa, I'll just do Van, is greater than Alex. So therefore, Vanessa has a greater angle of view. That's the wording. Angle of view. All right. Last question. So, a ladder leaning against the wall makes an angle of 31 degrees with the wall. The ladder just touches a box that is flush against the wall and the ground. The box has a height of 64 centimeters and a width of 27 centimeters. How long to the nearest centimeter is the ladder? So let's kind of make this picture make a lot more sense. So we have a box, right? And that would be this rectangle that I'm going to highlight in purple here. So this is the box. The box. And then you have this ladder, this A to C here. This is your ladder. I know I'm going to need to put labels on that line, so I'm just going to try and work off to the side here. Here's your ladder. All right, and then that makes this right here, the one I'm doing in blue, right here. This would be the wall. All right, so you have a ladder leaning against a wall, and then there's that box that's kind of wedged between the ladder and the wall. All right, so let's fill in the piece of information, the other piece of information it's giving us. So the 31 degrees here, well, that's already put on the graph, or the picture. So this angle right here is 31. And then it's saying that the box touching the wall and the ground, the box has a height of 64. So that means this distance right here of the box, this one, is 64. And then it's saying that the width is 27. So right here, this is 27. So how long to the nearest centimeters of the ladder? All right, so really what I'm looking for is how long is it to go from A to C, okay? So we have the big picture question. Remember triangle notation, it's saying I'm looking for a side length AC. Well, can we see that we actually have AC is broken into two kind of tiny triangles here that I'll draw in red. Like, notice how you have a triangle right here. Right here, you have this triangle, and then you also have this triangle right here. You have two triangles that are kind of created in here. Well, if I can find the hypotenuse of both of those triangles, so if I can find this distance right here, and let's call that one x, and if I can find this distance right here, let's call that hypotenuse y, well, if I take those two values and I add them together, well, then I'm going to find the length that I'm looking for, that side length AC. So we need to be able to find those hypotenuse. Well, let's look at this triangle 1. Let's call this one 1, and let's call this one 2. Well, triangle 1, let's draw it over here. We have this triangle that looks like this, where this is side length x. And because this is a wall, it's straight up and down, and the box is also set as a rectangle, you can actually assume that this is 90 degrees here, right? And then this angle right up here was 31 degrees. So, and it's also giving us that this right here is 27. So we are looking for x, all right? And we are dealing with a right angle triangle. Well, that means we're going to be able to use sine, cosine, or tangent. So based off what's given to us, let's decide what ratio we need to use. Well, I see I have an angle, and that angle, I also have its opposite side length, and I'm looking for the hypotenuse. So I'm going to be using the sine ratio, which is sine theta is op over hypotenuse. So in this problem, it's sine 31 degrees. Our opposite is that given 27 that we have, and the hypotenuse is what we're looking for. It's that x. So let's do a little algebra and solve for that x. So first thing we need to do is multiply both sides by x. So that means these cancel. You get x sine 31 degrees is equal to 27. And now divide both sides by sine 31 because we want to get rid of this. So you have to move it over to the other side by dividing it out. So these cancel. And you get x is 27 over sine 31. And now it's just a calculator problem. So go 27 divide by sine 31. I get an x value of 52.4 meters. And did it say to round? to the nearest centimeter. Okay, so we'll just leave it as one decimal place, and then we'll just round it at the end. Oh, sorry, and that's not meters in the first place, because this unit was centimeters. So this is actually centimeters. Okay, so we found x, right? So we have AC. Just don't get lost in all this math we're about to do. We have AC. We first found our side length 52.4. So now all we need to do is we need to also find y, okay? So we need to find the side length of our second triangle. So if we have this second triangle, triangle 2, well, that is looking like this, where we have this side length here. Okay, well, what piece of information is given to us? Well, we know this side length right here, this is 64 centimeters. We know this to be 90 degrees, because it's 90 degrees right here. Well, I actually don't have anything else. This is y right here. So, as it stands right now, I can't solve this triangle because I don't know this angle, and I also don't know this angle. But if we use the laws of triangles that say that all the sum of angles in a triangle need to add up to 180, well, let's look at the big triangle. So triangle ABC. So triangle ABC. So the ones that aren't broken up. Well, this angle up here is 31. 31. This angle right here is 90. This angle right here is the same angle as this one right down here. So let's get this angle right here. And this angle would be 180 minus the 31 minus the 90. And that's going to give you 180 minus 90 minus 31. You're going to get 59 degrees. So that means this angle would be 59 degrees, which we just drew a smaller picture of it over here. So now you have this to be 59 degrees. Okay, now that you have an angle, you can solve this. What do we have, and what are we looking for? Well, once again, we are looking for the hypotenuse, and we have a side length that is opposite the angle. So you're going to be using the sine ratio. So sine theta is opposite over hypotenuse. So sine of 59 degrees is opposite, being 64, over y. Now rearrange the problem for y, so multiply both sides by y. You get y sine 59 degrees, these cancel, is equal to 64. Now divide both sides by sine 59. Divide this by sine 59. These cancel. You get y is equal to 64 divided by sine 59, 74.7 centimeters. Okay, so that means you found this y to be 74.7 centimeters. So that means our total length is just the addition of these two. So 52.4 plus 74.7, you get 127.1 centimeters, but it wanted us to round to the nearest centimeter, so 127 centimeters. That is what the length of that big side length, this big side length right here. And that's the length of the ladder. So therefore, the ladder is 127 centimeters. And that's it for now. All right, so no new content taught. It's just seeing it put into practice for 4 different examples. So we have lots of homework to practice it, and I'll see you in class. Bye for now.